let's compute the following integral. Note very carefully here that the inside integral, which is the integral between 0 and t of sine squared t dt, we are integrating with respect to t between 0 and t. This integral here doesn't depend on x. We can take it outside. It's like a constant that doesn't depend on x. Okay? So we can solve this integral by first integrating with respect to x, which is surprising. Okay? And after that, we can integrate with respect to t. Nothing is going to change. Or we can do this one first, and after that, we integrate with respect to x. So nothing is going to change. If we do integrate with respect to x, we will have k will be the integral between 0 and t sine squared t dt, and after that we're going to integrate between 0 and x dx. Here, this integral is just x because we have 1. So therefore k is going to be x, the integral between 0 and t sine squared t dt. Okay, how can we do this one here now? Okay, we know that the cosine of 2t is, because we need the sine, it's going to be 1 minus 2 sine squared of t. And adding minus 1 to both sides and dividing by 2, I get 1 minus cosine 2t over t is sine squared of t. And therefore, I can get k as the integral between 0 and t, 1 minus cosine of 2t over t dt. And I can simplify one more time. I take the 2 outside, and I have 1 minus cosine 2t dt. I can simplify one more time, get the integral dt minus the integral between 0 and t of the cosine of 2t dt. I don't forget the 1/2, so I have 1/2. Here I have t between 0 and t, which is 1 between 0 and t, and therefore it's t between 0 and t, and I have here 1/2 sine of 2t between 0 and t, and therefore I have 1/2 t minus 1/2 sine 2t. Okay, and the sine of 0 is 0. And therefore, my integral, k, I need to multiply by x to get k. Therefore, k is going to be x over 2 times t minus 1/2 sine 2t. Okay, it's a function that depends on two values, x and t.